Hello everyone. So this is our third and last hour on motion in 1D. Today we will be doing calculus based problem, graph based problem and relative motion in 1D. So without wasting time, let's start with the first example. If the position in meter of a particle changes with time in second as x equals to 4t square plus 60 minus 4. Find the velocity and acceleration at time equals to 2 seconds. So they have given me the position as a function of time and they are asking me velocity and acceleration at time equals to 2 seconds. From the basic definition of velocity, we know that velocity equals to dx by dt. And they have told me how does the x changes with time, and x equals to 4t square plus 60 minus 4. So in place of x, substitute this. You can say velocity equals to the rate of change of x, which is 4t square plus 60 minus 4 upon dt. You know that the differentiation of 4t square plus 60 minus 4 will be 4 into differentiation of t square 2t plus 6 into differentiation of t with respect to t, which is 1, minus differentiation of 4, which is a constant, that becomes 0. So on differentiating, you get 8t plus 6. Now you know velocity at any time t. Now you know velocity at any time t. At time equals to 0, velocity is 6. At time equals to 1, velocity is 8 plus 6, that is 14. At time equals to 2, velocity is 8 into 2 plus 6, that is 16 plus 6, that is 22. So now you know velocity at any time t. They are asking you what is the velocity at time equals to 2 seconds. So at time equals to 2 seconds, velocity will be equal to 8 into 2 plus 6. In place of time, substitute 2. So you get 16 plus 6, which is nothing but 22 meter per second. Now you need to find acceleration. From the basic definition of acceleration, we know that acceleration is the rate of change of velocity with respect to time. So acceleration equals to dv by dt. And we know that velocity at any time t is given by 8t plus 6. So if the velocity at any time t is given by 8t plus 6, we can write acceleration as the rate of change of 8t plus 6 with respect to time. Now differentiation of 8t gives you 8 plus differentiation of 6 gives you 0. So what you get in the end is acceleration is nothing but 8. You can see here acceleration came out to be 8 meter per second square. It's a constant. So what is the acceleration at time equals to 0? 8 meter per second square. At time equals to 1, 8 meter per second square. At time equals to 2, 8 meter per second square. So the acceleration is constant at all times. So we can say the velocity at time equals to 2 is 22 meter per second. And the acceleration at time equals to 2 is 8 meter per second square. Okay. Let's see the next example. If the velocity in meter per second of a particle changes with time t as v equals to 6t square minus 4t plus 8. Find the acceleration at time equals to 1 second and displacement from time equals to 0 till time equals to 1. So here they have given me velocity as a function of time. They have given me velocity as a function of time and they are asking me acceleration at a particular time and displacement within a particular range of time. So first of all, let's find out acceleration. From the basic definition, we know that acceleration equals to dv by dt. If you need to find acceleration, you just need to find the rate of change of velocity with respect to time. So in place of velocity, substitute beta 6t square minus 4t plus 8. When you substitute this, you get differentiation of 6t square minus 4t plus 8 with respect to time. The differentiation of 6t square with respect to time is 6 into 2t. The differentiation of minus 4t with respect to time is minus 4 and the differentiation of 8 becomes 0. So here you can write this to be equal to 12t minus 4. As per the problem statement, they are asking you acceleration at time equals to 1. You have got here acceleration at any time. You know that acceleration at any time t is 12t minus 4. So at time equals to 0, acceleration will be equals to 12 into 0 minus 4. At time equals to 1, you can write acceleration as 12 into 1 minus 4, that is 8. At time equals to 2, acceleration is 12 into 2 minus 4, that is 24 minus 4, that is 20. So now you know acceleration at all time. They have asked you acceleration at time equals to 1. So in place of time, just substitute 1. So what you get is at time equals to 1 second, acceleration will be equal to 12 into 1 minus 4, that is 8 meter per second square. Easy. Now let's do the next part. You also need to find displacement from time equals to 0 to time equals to 1. From the basic definition of velocity, you can say that velocity is the rate of change of position with respect to time. You can bring this dt up here and multiply. So you will get dx equals to v dt. You know that the infinitely small change in position dx equals to the instantaneous velocity times the infinitely small change in time. Now, if we integrated both the side, we will get the expression that integral dx equals to integral v dt, or integral dx gives you x, which is the total displacement, equals to integral v dt. But here we need to substitute proper limits on the right hand side. So we can say the displacement is nothing but integral v dt, and in place of v I have substituted 6t square minus 4t plus 8, and there is a dt, and we have placed the limit from 0 to 1. Lower limit of time is 0, upper limit of time is 1 always. So integrating 6t square, what do we get? Integration of 6t square dt gives you 6t raised to the power of 3 by 3. Integration of minus 4t dt gives you what? Minus 4t dt. Integration of this gives you minus 4 times integration of t dt, that is t square by 2. And integration of 8 dt, integration of 8 dt gives you what? Integration of 8 dt, sir, gives me 8 into t. So when you integrate this, each term, you get x equals to 6 t cube by 3 minus 4 t square by 2 plus 8t. We need to substitute limit. Lower limit is 0 because we have to integrate from time equals to 0 till time equals to 1. So lower limit 0, upper limit 1. Always substitute upper limit minus lower limit. So first, in place of t, substitute 1 everywhere. Then in place of t, substitute 0 everywhere. So you can further write this as 6 3 2t cube, 4 2, here you get a 2, minus 2t square plus 8t. Lower limit 0, upper limit 1. So in place of t, first substitute 1. So you get 2 into 1 cube minus 2 into 1 square plus 8 into 1, minus, in place of t, substitute 0. So you get 0 minus 0 plus 0. So here this 2 get cancel out. You get x equals to 8 meter. Always substitute upper limit minus lower limit. Okay. Let's see the next example. This one is really useful. If the velocity in meter per second of a particle changes with position in meter as v equals to alpha x square, find the acceleration at x equals to 1 meter. As soon as I give this problem in classes, v equals to alpha x square, determine the acceleration at x equals to 1 meter, what students do is that they say, sir, differentiating velocity, you get acceleration. So here you will get acceleration equals to alpha into 2x. So acceleration equals to 2 alpha x at x equals to 1. Acceleration will be equals to 2 alpha. This is what most of the students do. And this is wrong. Why? Beta, you need to understand acceleration is not equal to dv by dx. Here you are differentiating v with respect to x. Acceleration is not equal to dv by dx. Acceleration equals to dv by dt. We know that acceleration equals to dv by dt or d square x upon dt square, or it can be written as v dv by dx. So as acceleration can be written as v dv by dx, we can find acceleration using this. As per the problem statement, it is given that v equals to alpha x square. If I differentiated both the side, I will get dv equals to differentiation of alpha x square. Alpha is treated as a constant, so it can be taken out of the integration. The differentiation of x square, will give you 2x dx. So what we get here is dv equals to alpha outside 2x dx. So from here, if you bring the dx down, you get dv by dx equals to 2 alpha x, right? So we get dv by dx equals to 2 alpha x. So once we know dv by dx, multiplying v and dv by dx, we can get acceleration. So since we know that v equals to alpha x square, and since we know that dv by dx is 2 alpha x, when we multiply them, we will get acceleration. So we will get acceleration equals to v into dv by dx, that will be equals to alpha x square into 2 alpha x, that gives me 2 alpha square x cube. So the acceleration of this particle is 2 alpha square x cube. Now as per the problem statement, I need to find the acceleration at x equals to 1. Now in place of x beta, substitute 1. So we get that acceleration equals to, at x equals to 1, acceleration equals to 2 alpha square into 1 cube, which is nothing but 2 alpha square. Okay, let's see We know that the slope of y-x graph gives us what? So the slope of y-x graph gives us dy by dx. And the area under y-x graph gives us integral y dx. So if you have any y-x graph and you draw the tangent at any point, and if this tangent makes an angle theta, when you draw this tangent at x equals to x dash, we say that the slope of the graph is nothing but tan theta, which is nothing but the value of dy by dx at x equals to x dash. This is the simple thing you have to keep in mind. So the slope of y-x graph gives you dy by dx, and the area under the y-x graph gives integral y dx. Let's understand the second thing as well. If you have a y-x graph and let's say y is changing over a range of x. So if you look at the area under the graph from x equals to x1 to x equals to x2, the area under the y-x graph from x equals to x1 till x equals to x2 is nothing but integral y dx from x1 to x2. So let's visualize the graph. At a point on graph, we have drawn a tangent. Now this tangent, if it makes an angle theta, then the slope of the graph is tan theta. And this shaded area represents integral y dx. So the slope of the graph, the slope of the y-x graph gives us dy by dx, and the area under y-x graph gives us integral y dx. Now let's talk about three important graphs. The first graph, the xt graph, the position time graph. If you have position time graph, what will the slope of position time graph at any point give you? Sir, the slope of position time graph will give me dx by dt. If the slope of y-x graph gives you dy by dx, then the slope of xt graph will give you dx by dt, and dx by dt is nothing but velocity. So the slope of position time graph gives us velocity. Slope of position time graph gives me dx by dt, which is also known as velocity. Now what does the area under xt graph gives you? If you have got area under xt graph, it has to be nothing but integral x dt. Which physical quantity is displacement into time? Velocity into time is displacement. Which physical quantity is displacement into time? Which physical quantity is displacement into time? So there is no such physical quantity defined. So there is no quantity which has got physical significance as displacement into time. So we say that the area under xt graph gives us integral x into dt, the instantaneous position into infinitely small frame of time, and there is not any predefined quantity. We have a name for this. Okay. Now rather than having xt graph, if we have vt graph, then the slope of vt graph, just like the slope of y-x graph gives us dy by dx, the slope of vt graph will give me dv by dt. Once the slope of vt graph gives me dv by dt, what is dv by dt? So the rate of change of velocity with respect to time, and the rate of change of velocity with respect to time is nothing but acceleration. So the slope of vt graph gives me dv by dt, which is nothing but acceleration. What does the area under vt graph gives me? So the area under vt graph gives you integral v dt. What is the meaning of v? Sir, velocity, instantaneous velocity. What is the meaning of dt? Infinitely small frame of time. What does the instantaneous velocity times an infinitely small frame of time gives me? So sir, if you take the instantaneous velocity of a particle and multiply it with infinitely small frame of time, what you will get is infinitely small displacement. Right? So integral v dt gives me displacement. Why? Because integral v dt can be thought of as integral dx, and integral dx gives me the displacement. So the area under vt graph gives us displacement. Now the next one, the at graph, acceleration time graph. What does the slope of acceleration time graph gives us? The slope of acceleration time graph gives us dA by dt, the rate of change of acceleration with respect to time. Which quantity is called the rate of change of acceleration with respect to time? It's called jerk. So jerk is nothing but rate of change of acceleration with respect to time. No need to remember this. If you can, it's okay. If you can't, it's okay. So jerk is nothing but the rate of change of acceleration with respect to time. What is the area under the at graph? The area under yx graph gives integral y dx. So the area under at graph gives integral a dt. What is a? Acceleration. What is dt? Infinitely small frame of time. If you take the acceleration and multiply it with infinitely small frame of time, what do you get? The infinitely small change in velocity. So you can write integral a dt to be same as integral dv, and when you integrate dv, you get the overall change in velocity. So the area under acceleration time graph gives me the change in velocity. I will like you to pause the video here and memorize these things before you try to attempt any question on graphs. So now let's practice some question based on graphs. The first problem. From the xt graph of two particles A and B, compare the velocity of A and B. So here in the graph we have got position time graph of two particles, a particle A and another particle B. You need to find the ratio of their velocity. How do you get velocity from the position time graph? How do you get the velocity from the position time graph? One can say that the slope of position time graph gives us the velocity. The slope of position time graph gives us the velocity. What is the velocity of this particle A? Sir, when we look at the position time graph of particle A, the curve is a straight line. So this means that if I draw tangent at any point, I will get the same line. What will be the slope of these lines? Sir, the slope of these lines will be tan 60. So I can say from here velocity of A must be equal to tan 60. Now, what has to be the velocity of B? To find the velocity of B, draw a tangent at any point on the xt graph of B. When you draw the tangent at any point, you will get the same line. And this line will make an angle of 30 degree with the time axis. So the slope of graph B is nothing but tan 30. So the velocity of particle B has to be equal to tan 30. So remember that the slope of position time graph gives us the velocity. So we can say velocity of A equals to tan 60 equals to root 3 meter per second. Velocity of B equals to tan 30 equals to 1 by root 3 meter per second. In the question, they have asked me what is the ratio of velocity of A to B. What is VA by VB? So VA by VB has to be simply root 3 upon 1 by root 3. Root 3 upon 1 by root 3 is nothing but 3. So the ratio comes out to be simply equal to 3. Let's move on to the next example. From the velocity time graph, determine the average velocity from time equals to 0 to time equals to 10. So here they have given me a velocity time graph. We need to find the average velocity from time equals to 0 till time equals to 10. Sir, what is average velocity? Sir, average velocity is nothing but total displacement upon total time taken. Now, how to find the average velocity? So to find average velocity, you need total displacement and you need total time taken. They are asking us what is the average velocity from time equals to 0 till time equals to 10. So for this, we already know what is the time frame, sir. The time frame is 10 seconds. Now we need to find the total displacement. What will be the total displacement of the particle in the 10-second time frame? So from the velocity time graph, we need to find the total displacement. How to find? Sir, the area under VT graph gives us the displacement. So how to find the displacement from time equals to 0 till time equals to 10? Sir, that will be nothing but this shaded area. So we can say average velocity is nothing but total displacement upon total time taken. The area under the velocity time graph gives us the total displacement. So we will get area under VT graph is the total displacement upon total time taken. Now this area is in the shape of a trapezium. How do you write area of trapezium? Half into sum of parallel side into height. The length of these two parallel sides 1 and 2 will be how much? So sir, this length starts from 0 and goes up to 10. So this length has to be 10. This upper length starts from 5 and goes up to 10. So this length has to be 5. And this height has to be equal to 10. So you get area under VT graph as half into sum of parallel side 10 plus 5 into the height, which is 10 upon 10. So this 10 get cancelled. You get 10 plus 5 by 2, that is 15 by 2, which is nothing but 7.5 meter per second. So the average velocity can be found looking at this VT graph equals to 7.5. While teaching you the topic of average value of y over a range of x, I told you that whenever you have to find the average value of y over a range of x, simply do the area under the graph upon change in x. That can be used also here, the area under the graph upon the change in x, right? Let's move on. From the VT graph, determine the acceleration at time equals to 4 seconds and time equals to 8 seconds. So here we have got a VT graph. First of all, how do we find the acceleration from a velocity time graph? Sir, the slope of velocity time graph, the slope of VT graph gives us acceleration. The slope of VT graph gives us acceleration. I ask you, from time equals to 0 till time equals to 5, the velocity of the particle is increasing, decreasing, or constant. The velocity of the particle is increasing, decreasing, or constant. So you will say, sir, see, the question is what is happening to velocity from time equals to 0 to 5? Sir, at time equals to 0, velocity is 0. Time equals to 1, velocity is a little positive. Time equals to 2, velocity is more positive. Time equals to 3, velocity is more positive. So, sir, velocity is increasing. So, from time equals to 0 till time equals to 5, velocity is increasing. If the velocity is increasing, it means that particle has some positive acceleration. Now, I ask you the next question. From time equals to 0 till time equals to 5, the acceleration of the particle is increasing, decreasing, or constant. Sir, we get the acceleration from the slope of the velocity time graph. Here you have given us velocity time graph and you are asking us from time equals to 0 till time equals to 5, the acceleration is increasing, decreasing, or constant. I just need to focus on from time equals to 0 to time equals to 5, is the slope of the VT graph increasing, decreasing, or constant? If from time equals to 0 till time equals to 5, the slope of the graph increases, then the acceleration is increasing. From time equals to 0 till time equals to 5, if the slope of the graph decreases, then the acceleration is decreasing. From time equals to 0 till time equals to 5, if the slope of the graph is constant, then the acceleration is constant. So, sir, how to know whether the slope is increasing, decreasing, or constant? So, better see. Think of multiple points on this graph from time equals to 0 till time equals to 5. What is the slope? The tan of the angle made by the tangent. If you visualize tangent at all these points, all the tangent will be common. So from time equals to 0 till time equals to 5, as the slope is constant, you know that acceleration is constant. Now, just by looking at this data, can you tell me what is the acceleration from time equals to 0 till time equals to 5? So see, as the slope of the graph is constant, yes. Acceleration is constant, yes. As the acceleration is constant, we can simply write acceleration as the change in velocity upon the time taken. At time equals to 0, velocity is 0. At time equals to 5, velocity is 20. So in these 5 seconds, the change in velocity is 20 and the time taken is 5. So acceleration is 4 meter per second square. So acceleration is constant throughout and equal to 4 meter per second square. If they ask you, tell me what is the acceleration at time equals to 2.33 seconds, you will say, sir, again 4. Why? Because from time equals to 0 till time equals to 5, acceleration has a constant value of 4 meter per second square. So even at time equals to 2.33 seconds, acceleration will be equal to 4 meter per second square. Okay. Now, so I know that at time equals to 4 seconds, acceleration has to be equal to 4 meter per second square. What will be the acceleration at time equals to 5, 6, 7, 8, somewhere here, 8 seconds. You will again say, sir, from time equals to 5 till time equals to 15. From time equals to 5 till time equals to 15. The slope of the graph is again constant. If I draw tangent at any point, I will get the same lines. The slope of the graph is again constant, so acceleration is again constant, but as I know that the velocity drops from 20 to 0. As the time increases from 5 to 15, I know that acceleration is negative. So how much is the acceleration? You can say the acceleration in the time range from 5 to 15 again have to be change in velocity upon time taken. At time equals to 5, velocity is 20. At time equals to 15, velocity is 0. So the change in velocity is final minus initial upon the time taken. From 5 second to 15 second, the time frame is 10 second by 10. So the acceleration comes out to be minus 2 meter per second square. So time equals to 5 till time equals to 15. Acceleration is constant, equals to minus 2 meter per second square. So even at time equals to 8 second, the acceleration is minus 2 meter per second square. As the slope of the graph is constant from time equals to 0 till time equals to 5, acceleration is constant. And this acceleration will be equal to the change in velocity upon time taken. From 0 till 5, the change in velocity is 20 upon time taken 5. So it will be equal to 4 meter per second square. So at any time from time equals to 0 till time equals to 5, the acceleration is constant, equals to 4 meter per second square. So even at time equals to 4 second, acceleration will be 4 meter per second square. Right? Now, what will be next case? Again, slope is again constant from time equals to 5 till time equals to 15. So acceleration is again constant. The acceleration at time equals to 8 will be equals to the change in velocity upon the change in time. The change in velocity is final 0 minus initial 20 upon the time frame. The time frame from 5 to 15 is 10 seconds. So you get minus 2 meter per second square. So from time equals to 5 till time equals to 15, acceleration is constant, equal to minus 2 meter per second square. So even at time equals to 8, the acceleration will be equal to minus 2 meter per second square. In this question, if they ask you what is the displacement of the particle, so how to find displacement from the velocity time graph? So the area under the velocity time graph gives us displacement. So also the displacement during the journey x will be nothing but the area of this triangle, and the area of this triangle will be half into base 15 into height 20. So when you solve it out, you get here a 10. So 150, 15 into 10, that comes out to be 150 meter, right? Let's see next example. If the acceleration time graph of a particle looks as shown starting from rest, so this is the acceleration time graph. You have to choose one of the four options. First option, the velocity of particle increases continuously. The velocity of particle decreases continuously. The velocity of particle first increases then decreases. The velocity of particle first decreases then increases. So the graph shows the acceleration time graph of a particle, and they are asking you to comment on the velocity. What is happening to velocity? Velocity increases continuously, decreases continuously, first increases then decreases, first decreases then increases. What is the case? So sir, see, from the graph I can see first the acceleration of the particle increases and then the acceleration of the particle decreases. Most of the students look at this graph and mark out option 3. As the acceleration first increases and then decreases, the velocity will first increase and then decrease. But that is wrong. To make you understand this, I will ask you a simple question. Let's say a person has an acceleration of 5 meter per second square. It means that the velocity will increase in the direction of acceleration by 5 meter per second per second. So every second the velocity will increase at a rate of 5 meter per second. Now let's say the acceleration of this person reduces to 2 meter per second square. So now the acceleration will be 2 meter per second per second. Now every second the velocity will increase by 2 meter per second. Question is, if the acceleration of the particle decreases, what happens to its velocity? If the acceleration of a particle decreases, what happens to its velocity? Sir, if the acceleration of a particle decreases, then the velocity increases at a lower rate. If the acceleration of a particle decreases from 5 to let's say 2, then the velocity increases at a lower rate. It does not mean that the velocity decreases. Okay, so first the acceleration increases, so the rate of increase of velocity keeps on increasing. Then when the acceleration decreases, then the rate of increase of velocity decreases, But till the time the particle has a positive acceleration, the velocity will keep on increasing. Hence, the correct answer to this question is the velocity increases continuously, which is option number 1. Till the time acceleration is positive, the velocity will keep on increasing. This is the line you have to keep in mind. Let's move on. For the given velocity time graph, draw the acceleration time graph. So let's say this is the velocity time graph. If this is the velocity time graph of a particle, what will the acceleration time graph look like? We have got 4 options and you have to choose the right one. So sir, how do we get acceleration from the velocity time graph? Sir, the slope of the velocity time graph gives the acceleration. The slope of the velocity time graph gives the acceleration. So you can say, sir, let's call this time t1, this time t2, and this time t3. Okay. From time equals to 0 till time equals to t1, the slope of the velocity time graph is constant and the velocity is increasing, so the acceleration has to be positive constant. So from time equals to 0 till time equals to t1, the acceleration have to be positive constant, so acceleration won't change with time. From time equals to t1 till time equals to t2, the velocity of the particle do not change with time. If the velocity do not change with time, what is the acceleration? 0. So from time equals to t1 till time equals to t2, the acceleration of the particle is 0. Also, you can think using the slope. If I draw a tangent at any point between t1 and t2, it will be a straight line parallel to the time axis. So angle made by this line with the time axis is 0 and tan 0 is 0. So the slope is 0. As the slope of VT graph from time equals to t1 till time equals to t2 is 0, I can say that acceleration has to be 0. So from time equals to 0 till t1, acceleration is positive constant. From time equals to t1 to t2, as the velocity do not change, acceleration is 0. From time equals to t2 to t3, as the velocity decreases, but again at all point I will get the same tangent, that is acceleration is negative constant. So which graph suits it? Sir, acceleration increases, then constant, then decreases. So till the time acceleration is positive, velocity will continuously increase. So this can't be the answer. By the way, the graph of velocity time for this acceleration time will look like this. Acceleration increases, slope of velocity time increases. Acceleration is constant, slope of velocity time remains constant. Acceleration is positive and decreasing. The slope of velocity time will be positive and decreasing. So this is somehow your velocity time graph will look like for this acceleration time graph. The second option acceleration is positive, then acceleration is 0, then acceleration is negative constant. So positive constant, 0, negative constant. Yes sir, this is the answer. So the acceleration time graph for this velocity time graph is positive constant, then 0, then negative constant. So the correct answer is option 2. Let's see the next example. For the given velocity time graph, draw the position time graph. For the given velocity time graph, draw the position time graph. For this same graph, in the last slide, we have drawn the acceleration time graph. For the given velocity time graph, now we need to draw the position time graph. So these are the 4 options with us. Sir, what is given is velocity time graph, and what you are asking is position time graph. The slope of position time graph gives us velocity. In the velocity time graph, I can see velocity first increases, then the velocity is constant, then the velocity decreases, but the velocity always remains positive, right? So velocity first increases, then remains constant, then decreases, but the velocity is always positive. So when we think of the displacement time graph, the slope of displacement time graph should first increase, then remains constant, and then decrease. So this is somehow the displacement time graph will look like, and which is nothing but our option number 1. So option number 1 is the right option. Let's move on to the next graph. From the given velocity position graph predict the acceleration at x equals to 2 meter. So here we have a velocity position graph and we need to tell what will be the acceleration of particle at x equals to 2 meter. Again, as soon as the student see, sir, a straight line on velocity position graph, it means that acceleration is constant. Nahi beta. The slope of velocity position graph gives you dv by dx and acceleration is not at all equal to dv by dx. Acceleration is equal to v dv by dx. They have given me velocity position graph and they are asking acceleration. What to do? They have given me velocity position graph. Sir, you haven't taught velocity position graph. You have taught xt, vt, at. So beta, this is the last one left out. So we are learning this with an example. Okay, sir. So from the velocity position graph, we need to find the acceleration. Sir, if we look at the graph, the graph is that of straight line. Yes. We did just one example just now. If v equals to alpha x square, then I asked you what is the acceleration at x equals to 1, right? So if I know the relationship between v and x, then I can find out dv by dx. And once I know v and once I know dv by dx, I can find out acceleration. So let's use it. So from the equation of straight line, we can say that the velocity equals to mx plus c. Sir, in place of y, in the equation of straight line, y equals to mx plus c. In place of y, we have written v. In place of x, we have written x because it's the displacement. Now, what is the slope of this graph and what is the y-intercept? So the slope is nothing but tan 45, which is 1, and the y-intercept is 2. So from here we get the relationship between v and x. So we can write as the slope is tan 45 equals to 1 and the y-intercept is 2. We get that equation equals to 1 into x plus 2, that is nothing but x plus 2. Now, once you have relationship between velocity and position, now you can find out dv by dx. If you know dv by dx and you know v, multiplying them, you know the acceleration. So from here, acceleration equals to v into dv by dx. If you differentiate it both the side, we get dv by dx equals to 1. So acceleration, which is v into dv by dx, becomes equals to x plus 2, which is v, x plus 2, which is v, multiplied by 1, which is dv by dx. So the acceleration comes out to be equals to x plus 2. They are asking me acceleration at position equals to 2 meter. So what will be the acceleration at position of 2 meter? 2 plus 2. So the acceleration will be equals to 4 meter per second square. So now we will talk about relative motion in one dimension. It's such an interesting topic, relative motion. First thing which I say you have to atmasat, you have to remember is that whomsoever observes the motion, he, her, itself assumes to be at rest. Observer assumes himself, herself, itself to be at rest. So the observer always assumes itself to be static. Now let's say we have this number line, and on this number line, this is the origin, x equals to 0. There is a person standing at x equals to a, and there is another person standing at x equals to b. Their positions will be, let's say, shown as position of A and position of B. I ask you, what is the position of B with respect to A? What is the position of B with respect to A? So you will say, sir, position of B with respect to A will be represented by this vector. So position of B with respect to A will be nothing but this vector, and this vector will be nothing but the difference in these two lengths, xb and xa. So you can say that this will be equals to xb minus xa. So remember, whenever I say xba, it means that position of B with respect to A, and the position of B with respect to A is nothing but xb minus xa, position of B minus the position of A. If I differentiate each term here with respect to time, I will get the rate of change of position of B with respect to A with respect to time equals to the rate of change of position of B with respect to time minus the rate of change of position of A with respect to time. What is the meaning of rate of change of position of A with respect to time? So velocity of A. What is the meaning of rate of change of position of B with respect to time? Velocity of B. And when I say the rate of change of position of B with respect to A, with respect to time, it means that velocity of B with respect to A. So if I differentiate each term, what I get is dxba by dt equals to dxb by dt minus dxa by dt. This term represents the velocity of B with respect to A. This term represents velocity of B, and this term represents the velocity of A. So we can say velocity of B with respect to A equals to velocity of B minus velocity of A. If I differentiate each term again with respect to time, now I will get the acceleration of B with respect to A equals to acceleration of B minus acceleration of A. So remember that velocity of 2 with respect to 1 equals to velocity of 2 minus velocity of 1. Let's talk more on this. So we have learned that position of B with respect to A equals to position of B minus position of A. Velocity of B with respect to A equals to velocity of B minus velocity of A. Acceleration of B with respect to A equals to acceleration of B minus acceleration of A. So easy. Now I ask you, what is the position of A with respect to B? If, let's say there are two persons A and B. If I ask you, what is the position of B with respect to A? It will be represented as xB. The position of B with respect to A is a vector originating at A and going up to B. So this vector represents position of B with respect to A. Now I ask you, what is the position of A with respect to B? So you have to start measuring from B. When I ask you what is the position of A with respect to B, so you are finding position of A with respect to B, it means that you are starting your measurements from B. B is the origin. B is the one who is fixed. B is the one who is static. So when you write position of A with respect to B, you think of a vector starting from B and going up to A. So this will be the position of A with respect to B. Can't you see both the vectors have same magnitude and they just have opposite direction? So we will say position of A with respect to B equals to minus times of position of B with respect to A. Position of A with respect to B equals to minus times position of B with respect to A. And once I have established this relationship, now I can differentiate. So I can say the rate of change of position of A with respect to B with respect to time equals to minus times the rate of change of position of B with respect to A with respect to time. So the velocity of A with respect to B equals to minus times the velocity of B with respect to A, right? So that becomes our next statement. Velocity of A with respect to B equals to minus times the velocity of B with respect to A. And similarly, differentiating again, we get acceleration of A with respect to B equals to minus times the acceleration of B with respect to A. Now let's understand this with an example. Let's say there are two friends, Ram and Sham. Ram going towards right with speed of 4 meter per second and Sham going towards right with speed of 6 meter per second. Taking the right hand side to be positive, I ask you, what is the velocity of Sham with respect to Ram? When I say what is the velocity of Sham with respect to Ram, Ram is the origin. We are measuring everything with respect to Ram. Ram is the origin. Ram will assume himself to be at rest. So what is the velocity of Sham with respect to Ram? You will say, sir, easy. Velocity of Sham with respect to Ram has to be velocity of Sham minus velocity of Ram. Velocity of Sham is plus 6. Velocity of Ram is plus 4. So velocity of Sham minus velocity of Ram will be plus 6 minus plus 4. Plus 6 minus plus 4 becomes 6 minus 4. That will be equal to 2 meter per second. Now see here, beta. There is a positive sign here. Plus 2 means that in the frame of Ram, Ram will say, I am fixed. And this person Sham, as seen by me, goes in the positive direction with a speed of 2 meter per second. And while solving this question, we assume the positive direction to be towards right. So in the frame of Ram, Ram will say I am fixed. And the Sham goes in the positive direction with a speed of 2 meter per second. Now, next question. So that is 2 meter per second towards right, 2 meter per second in the positive direction. What is the velocity of Ram as seen by Sham? In the frame of Sham, what is the velocity of Ram as seen by Sham? In the frame of Sham, Sham will say I am fixed. Sham will say I am fixed. and this ram has certain velocity. Let's see how much. We can say that velocity of ram with respect to sham equals to velocity of ram minus velocity of sham. If I have taken direction towards right as positive, velocity of ram will be plus 4, velocity of sham will be plus 6. So velocity of ram with respect to sham will be equals to plus 4 minus plus 6, and plus 4 minus plus 6 gives you minus 2. The minus sign here tells you that the velocity of ram with respect to sham is in negative direction. The direction you have assumed negative. So in the frame of sham, ram will go towards left with a speed of 2 meter per second. So that is 2 meter per second towards left. So here we have understood something. Velocity of A with respect to B equals to minus times velocity of B with respect to A. As seen by ram, sham has got velocity of 2 meter per second towards right. As seen by sham, ram has got velocity of 2 meter per second towards left. They have got the same magnitude, but they have got opposite direction. Now let's practice a question using the relative motion in 1D. A person moving with initial velocity of 2 meter per second and acceleration of 1 meter per second square is being chased by a car having initial velocity of 22 meter per second and acceleration of 5 meter per second square. If the initial separation is 150 meter, find the time after which the car will catch the person. Car has got acceleration of 5 meter per second square, initial velocity of 22 meter per second, person has got acceleration of 1 meter per second square, initial velocity of 2 meter per second, and the initial separation between them is 150 meter. Your mission is to find the time at which car will catch the person. To solve this question, you do not need relative motion at all. You can say, using the second equation of motion, the distance traveled by this person in time t will be equals to 1t plus half into 2 into t square. Using the second equation of motion, the distance traveled by a car in time t will be equals to initial velocity 22 into t plus half into acceleration 5 into t square. If I call this distance as x1 and this distance as x2, and t the time when car and person are at same position, that is the person has caught the car, the car has caught the person. So we can say that x2 has to be equals to x1 plus 150. x2 has to be equals to x1 plus 150, and you can solve for the time. But we are learning relative here, so we will use relative motion. We are solving in the frame of the person. When we are solving in the frame of the person will be fixed. So in the frame of the person will say, I am at rest, I am fixed, I am static, I am not at all moving. Now, what will the velocity of car will appear to be? What will the acceleration of the car will appear to be? The car is still 150 meter behind the person, and for the sake of solving, I will take the direction towards right as positive. So in the frame of person will say, I am fixed, I am static, I am not at all moving. The velocity of car with respect to person, the initial velocity of car with respect to person equals to initial velocity of car minus the initial velocity of person. Initial velocity of car is 22 meter per second. Initial velocity of person is 2 meter per second. So the initial velocity of car with respect to person has to be 22 minus 2. And 22 minus 2 is 20. So initial velocity of car with respect to person is 22 minus 2, which is 20 meter per second. Next, what will be the acceleration of car with respect to person? So we will say acceleration of car with respect to person equals to acceleration of car minus acceleration of person, and both are in positive direction, so we will substitute both as positive. So initial velocity came out to be 20 meter per second. Acceleration of car with respect to person equals to acceleration of car minus acceleration of person, that will be 5 minus 1, which will be equal to 4 meter per second square. So in the frame of person, the person will say, I am at rest. There is a car 150 meter behind me. The car has initial velocity of 20 meter per second and car has a constant acceleration of 4 meter per second square. How long it will take for car to reach the person? So from the second equation of motion, we can write from x equals to ut plus half at square, we can write 150 equals to 20t plus half into 4 into t square. Now multiply each term with 2, you get 300 equals to 40t plus 4t square. Divide each term with 4, you get 75 equals to 10t plus t square. And on solving this simple quadratic equation, t square plus 10t minus 75, we get the value of time. How? We can write t square plus 15t minus 5t minus 75 equals to 0. So take the t common, here you have got t plus 15, take the minus 5 common, here you have got t plus 15 equals to 0. So t plus 15 into t minus 5 equals to 0. So either t has to be equals to plus 5 or t has to be equals to minus 15. Minus 15 is not possible, that's why the answer has to be 5 seconds. So the time taken will be 5 seconds. So this is how we use relative motion to solve the questions of 1D. Now let's see a crazy case about relative motion in 1D. Two particles are projected up with speed of 40 meter per second and 30 meter per second. Determine the separation between them at time equals to 3 seconds. Two particles are projected up with speed of 40 meter per second and 30 meter per second. You need to find the separation between them at time equals to 3 seconds. No idea? Let's do it this way. I ask you different question. There are two friends on a road, friend A and friend B. The friend A goes towards right with a speed of 20 meter per second. The friend B goes towards right with a speed of 40 meter per second. As the velocity of B is more than the velocity of A, the separation between them is bound to increase. Let's say the initial separation between them is 20 meter. I ask you what will be the separation between them at, let's say, time equals to 3 seconds. So you will say, sir, in the frame of A, velocity of B with respect to A equals to velocity of B minus velocity of A. In the frame of A will be at rest. Velocity of B with respect to A will be velocity of B minus velocity of A, that will be 40 minus 20, that is 20 meter per second. So in the frame of A will say, bhai sahab, I am fixed, I am static, I am not at all moving. This person B has a velocity of 20 meter per second towards right, and the initial separation between me and B is 20. So in a time equals to 3 seconds, this B will move forward by a distance 20 into 3, that is 60 meter. So the separation of B from A will become equals to 60 plus 20, and 60 plus 20 is 80 meter. So in 3 seconds, the separation will increase from 20 and become equal to 80 meter. Why are you discussing that question here? Because in the example I just took, there was no acceleration of A and B. But in this example, as the ball has been projected upwards, they will have acceleration. But since they have the same acceleration, their relative acceleration will be 0. Listen to it carefully. Once you have projected a ball up with speed of 40 meter per second, I ask you what is the acceleration? You will say, sir, G down. Now I say you have projected another ball with speed of 30 meter per second upwards. What is its acceleration? You will say, sir, G down. We know that acceleration of B with respect to A equals to acceleration of B minus acceleration of A. Yes, sir. If the acceleration of B with respect to A is acceleration of B minus acceleration of A, and both have got the same acceleration, what will be the relative acceleration? 0. And since the relative acceleration will be 0, the relative velocity will be constant. So since in this case both the particles have same acceleration, their relative acceleration is 0. Since their relative acceleration is 0, their relative velocity will be constant. So here you can say, taking upward direction as positive, as after projection both have same acceleration, so the relative acceleration will be 0. For relative velocity UAB, the relative velocity of A with respect to B, you can write initial velocity of A minus initial velocity of B. I have taken upward direction as positive, so I will substitute the initial velocity of A as 40 and the initial velocity of B as 30. So I will get 40 minus 30 equals to 10 meter per second. So in the frame of B, B will say I am at rest. A has got an upward velocity of 10 meter per second. Since we both have the same acceleration, as seen by B, A will have no acceleration. The relative acceleration will be 0. As seen by A, since A have no acceleration, A will keep on moving with the constant velocity. As seen by B, since A keeps on moving with a constant velocity of 10 meter per second for 3 seconds, the relative separation between them will be 30 meter. So for relative velocity will be 10 meter per second. As the relative acceleration is 0, relative velocity will be constant equals to 10 meter per second. So the separation between the masses at time equals to 3 seconds will be nothing but 10 into 3, that is 30 meter. You could have even solved this question this way. If the first ball is projected with speed of 40, after 3 seconds its speed will be 10 meter per second. So for these 3 seconds, the average velocity will be 40 plus 10 by 2, which is 25. So the height attained will be 25 into 3, that is 75 meter. For the ball B, after 3 seconds, its velocity will be 0. So the average velocity for these 3 seconds for ball B will be 30 plus 0 by 2, that is 15. So the average velocity is 15 and the time frame is 3. So the height will be 45 meter. So the difference in their height is 75 meter minus 45 meter equals to 30 meter. But I personally like this relative motion concept when both the particles are projected under gravity, because when both the particles are projected under gravity, they have the same acceleration. Since they have the same acceleration, relative acceleration is 0, and since the relative acceleration is 0, relative velocity is constant. Let's see one more example based on this. If both the masses are projected simultaneously, determine the time after which they will collide. So there is a tower of height 90 meter. From the top of a tower, a ball A is projected downward with speed of 5 meter per second. And from the base of the tower, another ball B is projected up with a speed of 25 meter per second. You have to answer after how long these two particles will collide. This example is exactly same as asking you, there are two friends, Ram and Sham. Ram has got velocity of 5 meter per second towards right, Sham has got velocity of 10 meter per second towards left, and let's say initial separation between them is 150 meter. After how long will they collide? So you will say, sir, the rate of decrease of separation between them, the velocity of Ram is trying to decrease the separation at 5 meter per second, the velocity of Sham is trying to decrease the separation at 10 meter per second. So both the velocities are trying to decrease the separation. So the rate of decrease of separation will be 15 meter per second. Every second the separation between them will decrease by 15 meter. So as the separation decrease by 150 meter, the time taken will be 150 by 15, that will be 10 seconds, right? If I tell you that this question is exactly same as the Ram and Sham question, you might get perplexed a little bit, but it is exactly same. Reason being, since both A and B are projected under gravity, they have the same acceleration, g downwards, g downwards. Remember that acceleration is a vector quantity. Sometimes students think that since A is projected downward and it is going downward, its acceleration is plus g. And B has been projected upward and it will slow down, its acceleration should be taken as minus g. No. Acceleration is a vector quantity. Since both the particle A and B have the acceleration of same magnitude in same direction, their relative acceleration will be 0. Since their relative acceleration will be 0, their relative velocity will be constant. So let's see. As after projection, both have the same acceleration g downward, so the relative acceleration will be 0. As A relative is 0, we can say that the relative velocity will be constant. Relative velocity will be constant. It won't change with time. Now, velocity of B with respect to A. When we are finding velocity of B with respect to A in the frame of A will say, I am fixed, I am static, I am not at all moving. The velocity of B with respect to A will be nothing but velocity of B minus velocity of A. If I have taken upward direction as positive, I will write the velocity of B as plus 25 minus velocity of A. Velocity of A is minus 5. So you get 25 minus 5, minus becomes plus. So you get that velocity of B with respect to A is 30 meter per second. So in the frame of A will say I am fixed, I am not moving. And B has got an upward velocity of 30 meter per second and this relative velocity remains constant. Why? Because the relative acceleration is 0. So in the frame of A, A will say I am fixed. This B is 90 meter away from me and this B moves with a constant velocity towards me. So B will come and hit me after 90 by 3, that is 3 seconds. Okay. So in the frame of A, B moves with a constant velocity of 30 meter per second and strikes A after a time equals to 90 by 30, that is equals to 3 seconds. Sir, can we solve this question without using relative? Yes, you can. In a time t, the distance moved down by A will be equals to 5t plus half gt square. In a time t, the distance gone up by B will be equals to 25t minus half gt square. So when you add them up, it should be equal to 90. So from here, when you add them up, this half gt square part get cancelled. So you get 5t plus 25t equals to 90. Total distance 90. So 30t equals to 90 or t equals to 3 seconds. So you can do this question even without using the relative motion, but relative motion makes it easier. Let's see the next example. If both the masses are projected simultaneously, determine the time after which they will collide. So here we have got a tower. From the top of the tower, a particle A is projected upward with speed of 10 meter per second. And from the base of the same tower, a particle B is projected upward with speed of 50 meter per second. Question is, after how long they will collide if both of them are projected simultaneously at time equals to 0. Again, once projected, both of them will have the same acceleration. Yes, sir. Sir, since both of them will have the same acceleration, relative acceleration will be 0. As the relative acceleration will be 0, relative velocity will be constant. So, in the frame of A, A will say, I am fixed. In the frame of A, B will have an upward velocity of 40 meter per second and an upward acceleration of 0. How? Let's see. In the frame of A, how to find velocity of B? You will say initial velocity of B with respect to A equals to initial velocity of B minus initial velocity of A. If I take the upward direction as positive, initial velocity of B will be written as plus 50 minus initial velocity of A will be written as plus 10. So you get 40 meter per second. The plus sign here tells us that in whichever direction you have assumed to be positive, the velocity of B with respect to A comes out to be in that direction. So the initial velocity of B with respect to A will be 40 up, acceleration will be 0. And A will say, I am at rest, I am fixed. And the gap between them is 120 meter. So in the frame of A, B moves up with a constant velocity of 40 meter per second with no acceleration, as the acceleration is 0. In the frame of A, B moves up with a constant velocity of 40 meter per second and the initial separation between them is 120. The question is, after how long they will collide? So you will say, so the time of collision will be nothing but 120 by 40, that is equals to 3 seconds. Now sometimes in these type of question, they might ask you at what height above the ground they will collide. At what height above the ground they will collide. So once you know that the collision will take place at time equals to 3 seconds, come back to the ground frame. This ball B has been projected up with a speed of 50. After 3 seconds, what will be the velocity of B? So sir, acceleration is downward 10 meter per second square. So every second the velocity will decrease by 10 meter per second. So in 3 seconds the velocity will decrease by 30 meter per second. And at time equals to 3, the velocity of B will be upward 20 meter per second. So at time equals to 3, the velocity of B will be equals to 50 minus 30, that is equals to 20 meter per second. So for these 3 second time frame, what will you take the average velocity of B? You will take that the average velocity of B will be equals to initial 50 plus final 20 by 2, that is 70 by 2, that is 35 meter per second. So once you know that the average velocity comes out to be 35 and the time frame is 3 seconds, so the displacement has to be equals to average velocity into time, that is 35 into 3, that is 105 meter. So they both will collide at a height 105 meter above the ground. That's all in this third hour. See you guys with the next chapter, relative motion in 2D, the next time. Bye bye. So that's all for now. See you guys in the next hour.